Monte Carlo simulation, we always require a random number, which is we can get in Excel using equal to RAND and then parentheses. So if I just say enter, then it will give me a random number which is between 0 and 1. So I can double click on this cell again and then press enter, and again it will give me an entirely different number. So double click again, enter, double click again, enter, right? It's a random number. Now if I want a random number between -1 and 1, then what I have to do is just modify this equation a little. So instead of writing just RAND parenthesis, I will say 1 minus 2 into RAND. So now suppose I have a random number of 0.5, so it will multiply it by 2 and then subtract it from 1, so I will get 0. If I have a random number of 0, then it will just multiply by 2, which will be 0, and then subtract from 1, it will be -1. It will be 1. So therefore you can go from -1 to 1 if I use this equation. So again I enter here, I get 0.63, double click, enter again, I get 0.79. So it's again right now it's not showing a negative number, but if I keep trying to see, now it's got a negative number of 0.77. I can also copy this random number again here. So now I have two random numbers, one in column B and one in column C. Now let's write 1 here and 2 here, so that we can get a series or counting of these random numbers here, and then copy these random numbers down. So now we have a set of random numbers from 1 to 9, and let's call this column X, and then let's call this column Y. Now we can copy this number again until as much as we want. Let's do it until 1000. So right now I do it until 1000 here. Now we have 1000 number both in column X and column Y. So let's select both column X and Y and say insert, and then say scattered. Now we get a scattered plot which has this number plotted. Let's call this. So now this is a scattered plot of these numbers from -1 to 1 in x-axis and -1 to 1 in y-axis, and this is a rectangle with length of 2 and height of 2. Now here we have defined a rectangle. Now let's define a circle within this rectangle of radius 1. So we know that the equation of a circle is x square plus y square is equal to r square, but here we are defining a radius of 1, that's for x square plus y square is equal to 1. So now if we write if statement here, so I say is equal to if x square plus y square is let me put one bracket here, is less than 1, then write x, otherwise write 0. So now get this, and then again copy the same equation and say if x square plus y square is less than 1, then write y here. So now what I'm doing here is now copying x and y in these two columns if x square plus y square is less than 1, otherwise it will write 0. So I can copy this again now, and I can see that it copies the number, and then if I go until 1000, so now I can see that sometimes I have zeros and sometimes I have the numbers. So whenever the point is outside the circle, it gives a 0. Now if I plot this two series again, then instead of getting, I can delete this. So instead of getting a rectangle, now I'm getting a sphere, and the radius of the sphere is 1 and the center is 0 0, and it goes from -1 to 1. And this is how I have what I have done is selected the points which are within the circle, and if the points are not within the circle in this rectangle, then I just make them 0 and 0. So now I define a circle here. Let's put this graph here, and now let me again copy this equation and write it here, and say that if it's less than 1, then write 1 here, otherwise write 0. Okay, so I kept 0, and then again copy this equation and say write 1, and otherwise even write 1. So in this case it will always write 1, and in this case it will write 1 only when the point is inside the circle. Now again I copy these numbers and go down all the way to 1000 points, and then I see that sometime this column is 0 and sometime 1, but this column will always remain 1. So now if I sum all these numbers, it says sum and then goes down, and sum all these numbers. So I got 776, which is number of points which are within the circle, and then if I copy it again, so I get number of points which are on the rectangle. So obviously all the numbers are on the rectangle, so we will get 1000, and these are the numbers which are not in the rectangle, which are in the circle, but whichever is outside the circle is been removed. So now if I say what is this number divided by this number, so this will be equal to area of circle divided by area of rectangle, and that is equal to 780 divided by 1000. So now this is my area, but as we know that area of the rectangle is 4, so if I multiply this number by 4, I'll get the value of pi. Now you are wondering that value of pi is 3.14, so why it is 3.104? And this is because we have only 1000 points for calculating this pi. So if we increase the number of points, we will get much closer. So now let's double click on this pi and press enter. So I say the value of the pi has changed to 3.244, and this is because its value is again recalculated, and again because of the poor statistics my value fluctuates. But if I do this step again and again for thousands of times, then the mean will be 3.14. So another way to increase the statistics is just to go, instead of 1000 points we can go to 10,000 points. So suppose now I'm here and I just copy all these equations again, and then go down and go down and keep going down until suppose maybe let's go to 10,000 points. So now if I copy it very badly, no, it's going more than 12. Let's make it around 12,000. It doesn't matter. So we go up, and then in this sum, instead of putting 1000, let me put one more 0, and then same here. So I can see that now my value of pi is much closer. So if I click again and enter, says 3.14, I can click again, press enter, 3.148, click again and enter, 3.16. So now the fluctuation is much less, the standard deviation of the number is much less, and we are much closer to the mean value, which is 3.14. So if I, instead of using 10,000 points, if I use 100,000 points, then I will get much closer value of what it should be of the pi. So this is how we can calculate the pi. So we followed a simple step. We define a rectangle, then put a condition that whenever the point is inside the circle, choose that point. Then from that we get the area of the circle, and then from area of the circle we calculated the value of pi. I hope this tutorial will help. Thank you.
Hello everyone. In this tutorial I will show you how to simulate Brownian motion in an Excel sheet. To simulate a Brownian motion, we need to have a command called rand. So that is equal to rand and parenthesis. So this give a random number between 0 and 1. If we want a random number between -1 and 1, we need to modify this equation such that 1 minus 2 into rand, and then this will give us a random number between -1 and 1. Now I can copy this number again into another column, so I have two random numbers, and I can call this one as dx and this one as dy. And now let me center them. So now we can write 1 because it's the first number, and then now we can define x and y. So let's suppose x and y. So our initial position of the molecule will be at 0, and then it will move in a random direction of dx and dy. So to find the position of x, we have to say x is equal to x plus dx, and same here, say y is equal to y plus dy. Okay, so now we can copy these numbers to generate more dx dy's and then subsequently x and y. So let me center them. And now if we want to simulate this walk for 100 steps, then all I need to do is to copy them and go to 100 numbers. So this is 100 here. So now I have a random walk of 100 steps. So now if I choose this 2 column and insert a graph, then I can see that I have a chart which predicts the path of a molecule which is taking a random walk. So if I click on any cell 2 times and then press enter, this path changes. So what is a random walk? Random walk is if any particular thing which is moving in random direction without any bias for a particular direction and takes several steps, then that thing can end up at any position. And if you want to see that what that position will be, for that we can simulate a random walk. So every time we simulate a random walk, the end position can be anywhere within this graph, as you can see. So I hope this tutorial will help. Thank you.
Hi everyone, in this tutorial we'll talk about the simulation of random walk of large number of particles. In the previous tutorial we talked about the simulation using Excel sheet of one particle, and here I will show you how to simulate the random walk for large number of particles. So let's define the particles first. So let's say I have particles particle 1, and then I have particle like this, like suppose I have 100 particles like this, and then define the position. So let's define time is equal to 0 and position x and y are both 0. So all of the particles starts at origin, and so now this is our x and y. Now to define the movement, let's say time is equal to 1, and now because it's moving in the random direction, so we have to define a random variable. So let's assume that we want it to move in any direction, so and it should take a step either positive direction or negative direction. So how do we simulate that random step? So for that we need a random number, and as I told you in my previous tutorial also, so random number in Excel is equal to rand and parenthesis. So this will give you a number between, so you can double click and say enter again, so you can see it give you a number between 0 and 1. And if you have to define a number between 0 and 2, you multiply this number by 2 and this will give you a number from 0 to 2. And if you have to define number between -1 and 1, you subtract this number from 1. So how does it work is like, so it give you a random number between 0 to 2, and if you subtract it from 1, then it will give you -1 to 1. So suppose if I get a number less than um, 0.5, because from RAND I can get mine less than 0.5. So if I multiply by 2, it will be less than 1, and then if I subtract it from 1, it will be greater than 0. And if same way, I can get less than 0. So you can think about it, and it's not that tough. So now we defined this number, and same way we can define this number again. You can see I have two numbers, and then what I can do is I can take this step and add the initial step into it. So I say initial step plus this step. So this is not difficult, and you can say enter, and similarly I can drag it here, and you can see. So for y also I added a random number. So this is your movement at time 1, and you can drag that again into the 100 particles, and you can see. So this is your position at time 1. Now what I'll do is I'll copy the same thing and paste it here. So what will happen, because this is the beauty of Excel sheet, that now because I copied it and I didn't put any dollar signs on the numbers, I can see, you can, if I double click on this and check the formula, so what it does, it automatically moves the cell from B4 to E4. So now you can see that now I'm adding a random step to the position which was there at time is equal to 1. Now you can see that, so my position, so this is my position at time 1, and this is position 2, and I can do the same thing again and again, so as many times I want. So I say V, and then, so let me, I'm not updating the time again and again, so let's delete the time and then do it again and again. So you can see, you can see this, that I can generate the walk like this. So actually if you use VBA, then you can do this automatically, you don't even have to paste this, but this is more of a conceptual programming. I wanted to show you the concept, and that's why I'm doing it this way, because this make it much easier to understand. Otherwise you can just update the same cell again and again. You can see my simulations, some of the simulations I've shown, that it's not a tutorial but just a demonstration on how you can generate the movement of the particle. There's a nice animation on the another YouTube video, but here I'm just showing you the concept. So now you can see. So let's see, if I plot this points, say insert and say points, so you can see all of the points. So all of the points are at 0. So you can see all of the points are here at 0. Now if I plot these points, you can see that they have moved with time. So you can see that they have diffused away, right? And now if I plot these points, so you can see they are much more scattered now. And now if I plot these points, so they are much more scattered. And because right now the scale is not defined, so that's why you don't see the difference. So I can define the scale, and then you will see the difference. So let's do that. So what I can do is select this scale and say format axis, and say fixed -10 and maximum 10, and same way for this axis, and say format axis fixed -10 to 10 and say close, right? And then let's delete this point and let's take this point and say format axis fixed -10 and +10. You can see, oh, this one is format axis fixed -10 and 10, and now you will see the difference. So I can, let me make them same shape. Fixed 10 -10. This is already 10, but I want to fix it, so close. Now you can see the, so what I'll do is I'll double click on any cell and say enter. So you can see that at t is equal to 0, the particles were all at one place at 0, and then they diffuse away from the center, and with the time their movement from the center, or their distance from the center, increases, but it does not increase uniform, like the particles are not moving only farther away, they are moving in the random direction, but by probability some of the particle reaches farther away from origin as compared to the others. So this is just a demonstration of the concept. And if you know VBA, I have also provided a tutorial on how to use VBA. So in that case you can really use the animations, so you can animate this movement of particles, and the particles will move in the random direction. So so this is the conceptual work, and I hope this will help you understand the concept which is behind simulating the random walk. So I hope this tutorial will help, and if you have any questions, please comment on the YouTube, and if you like the video, please do give us your feedback. Hi everyone, in this tutorial we will talk about binomial distribution. So to understand the binomial distribution, the best approach is to take an example of a coin. So as we all know that we can flip a coin and we can get heads or we can get tails, and to get the probability of getting a head is 0.5, and the probability of getting a tail is 0.52, but let's call it 1 minus probability of getting a head, because if we don't get a head then we have to get a tail. So if we have a biased coin, we can also say probability of getting head is 0.2. In that case the probability of getting tail will be 0.8. So in this case what I'm saying is that the coin is altered so that it tends to get more tails as compared to heads. And so let's go back to 0.5. So now this is how I have defined it. If I change it to 0.2, 0.3, it says 0.7. The total probability is always um, 1. So now what is a binomial distribution? So binomial distribution is that if I flip the coin at several number of times, suppose n number of times, then how many times should I get a head? So let's talk about the probability of getting heads. So now suppose I flip the coin 3 times, so like let's 3 times. So in this case I can get a head, I can get a head, and I can get a head, so all 3 heads, or I can get tail, I can get a tail, or I can get tail. So this is very obvious. Other option is I can get head, I can get tail, I can get tail, or I can get head, I can get head, I can get tail. So So I can do it many times. So you can see that this is like so this one has two heads, so this has two heads, this has zero head, this has three heads, and this has uh, no, this one has one head and this has two heads, right? So we can say number of heads, right? So you can see that so you can do this combination, but as you might know about the combination, so we can get one head in three different ways. We can get head, tail, tail. We can get tail, head, tail, or we can get tail, tail, head, right? So what, how do you define that? So you have to say that combine, so you can say combin, and then you have to choose the number. So this is because these are three flips, so it is three. And then how many number I have to choose? So I say one, so I say, so you can see that the number of possible arrangement for this is three. And same way if I do here, because as you combine and say 3 2, so number of possible ways here is also 3, and here is also only 1, and here also uh, it is only 1. So the total possible number of ways is how you define it. So now probability of getting all the heads, because so what we have to say is, so this is our number of combinations, and now we have to say the probability. So what is the probability? So the probability is equal to so in this case we have all three heads, so we say probability raised to power, probability of getting heads raised to power 3. So this is our probability. We have all tails, so again we'll say probability, oh, we have to multiply uh, probability of getting tails 3 times, and here we have to say um, probability of getting head 1 time into probability of getting tail 2 times. And similarly here we have to say probability of getting head getting tail into probability of getting head 2 times. So this is your probability. So because the probability of getting head and tail is same, that's why this probability looks same. But if you change the number, if I say 0.2 here, then you can see all these probabilities are now different. And now because there are different combinations, so how do I calculate the probability of getting three heads? So or so I have to multiply the number of possible combinations with the probability. So I'll multiply both of these terms. So let's define this thing. So I have to do this, and same way I have to do this for all three others. So you can see that this is the probability of getting uh, heads for 3 throws. So I should have arranged it. So let's do this way. This is your 0, this is your 1, this is your 2, and this is your 3. So this is your probability of getting heads, and so for number of throws. So you can keep so because you are only throwing it for 3 times, so this is your maximum distribution. So you can plot these numbers. So we say insert and say scattered plot, and your select data and edit, and X number is this. So this is what we call the binomial distribution of the number of heads we can get for and what is the probability of getting the heads if we throw the coins 3 times, So probability of getting 0 head is 0.5, and then probability of getting all 3 heads is almost 0. So now if you change the, so you can see if I change it to 0.9, then it will change accordingly. So now the probability of getting 0 head is very low, and the probability of getting 3 head is very high. And same way you can say 0.5, and then the probability in the beginning increases and then it decreases. So this one, in this case I only took the example of so because I was showing you the main concept, so I took only 4 points. But let's try to simulate the distribution um, for around 100 throws. So let's delete this, and now if you want to do the 100 throws, so let's do this. So number of throws is equal to 100, right? And then we say probability of getting 0 head, so we say number of heads, and this is 0, this is 1, 2, and we can keep going for this. And then so what we have to do, so now we have to choose the combination. So we say combine, and then we choose the combination. So if we throw 100, how many ways we can get 0 heads, so that is one way only. And same way, let's uh, do this. We can put the dollar sign here so that we don't have to uh, copy the 100 for all this, or into all this column. So it will always refer to 100 throws, and we can also put this here instead. So yeah, so now you can see that so we can go this way. So you can see we can get all the combination. So the number goes very high as we go higher. And then let's see if we are doing it correctly. And now what is the probability of getting 0 head? So to get a 0 head, we have to get all of the tails. So what is that? So that will be equal to probability of tails. So let's put a dollar sign so that it doesn't change as we move down. And then we have to have how many tails, so that will be equal to 100, because we are doing 100 minus number of heads. Number of heads is 0, so that will be equal to this number. So probability of getting all tails is very low. And then we can do this same way here. And now this, to get the total probability, so we'll say total probability of getting 0 number of head is equal to this into number of combinations. So this is your probability, and then we can also plot this like this. And then now let's do the same thing for 100. So you can see that now we have almost 100 throws. So if we go to 100 throws, uh, yeah, we did a mistake here. So here what we did is we only calculated the probability of getting tail, but we also have to multiply it with the probability of getting head. So here we have to say probability of getting head, and let's put that in the bracket. So we here, so what we did is that we said what is the probability of getting tails. So we get we didn't define what is the probability of getting heads also, so we have to multiply that too, and then we have to say this number, and and then we can also put that into the bracket. It's not necessary, but so now if we go below, now you can see that the probability should not go more than 1 in all of the way, and you can see that so if I sum all this probability, it should be equal to 1. If it's not equal to 1, then we did something wrong. So let's do sum, and then do the sum here, and you can see this probability sum is 1. So that means whatever we did here is correct. And now we can plot this numbers. So insert, or let's use this graph. Say select data, edit, and x value is number of heads we have, and y value is number or the probability. And this is what you call as your binomial distribution. So now this one looks much prettier as compared to what we had before, because we only had uh, less number of points there. So now, so you can see this is your so your distribution. So what we are seeing here is that the probability of getting 50 points is highest. So if you want to get 50 point, that is the highest probability that you will get 50 heads and 50 tails, because the probability here for getting a head is 0.5. But now if I do make change and do it 0.2, so you can see how does this distribution changes. So now the probability of getting 20 heads is highest, because the probability of getting a head is 0.2. And same way, if we do 0.9, then this is how it looks like. So this is how you define the binomial distribution. So I hope this will help you to understand the concept, and also how to simulate the binomial distribution in Excel sheet. So I hope this tutorial will help. Yeah, thanks. Hi everyone, welcome back. So in the last tutorial we talked about the Brownian motion and how to simulate two-dimensional Brownian motion in Excel sheet. So in this tutorial we will talk about the drift. How can we add a drift to a particle? Or a Brownian motion of a particle. So let's define drift in the x direction. So drift. So for the x direction we define drift to be let's say 1 right now, and for y direction also we say it 1. So drift for x, and this is for y, and then I say drift. So now if we have to add this drift, all I need to do is in these steps, so as I should label them because you might not have looked at the previous tutorial. So this is our random steps. So random steps, and this is our dx, which is the random step in x direction, and this is our dy, and uh, so let's do this. And and this one is our position x, and this is our position y. Oh sorry, I should not say 0 here, I should say here position x and position y. And so so what we are doing is that we are using a random number to generate a random step which is between 0 and -1 and 1, and then we are adding these steps together to come up with a random walk. So the particle is moving randomly in the x direction and y direction. So now how will we add drift to this? So to define the random walk, we added the random step to the initial position. So initial position was 0 and 0. The particles start from origin, and then we add random walk of delta x. So now here all we have to do is we have to add the drift into it, and then we have to put a dollar sign so that it always refer to cell G2 and doesn't change the reference as we move in the other cells. And same way for the Y, we have to add the drift of Y and say dollar sign here. And now as you can drag it down, you see that all the reference cell changed, my initial position changed, the random step changed, but the drift remained same because I put a dollar sign here. So now I can just select this two cell and double click on this one, and as you can see now, instead of going in the random walk, this particle is now moving in x and y direction. So this is your y direction, this is your x direction, and it's going in like a straight line. So now you can see if I make the drift for x is equal to 0, then you can see for x it doesn't have a preference, but for y it has a preference. It likes to go to the y side, but in a positive y side, but in the x direction it doesn't bother much. It can go in either way. And again you can see, so in x direction there is no drift, but in y direction there is a drift. So let me put the axis here. Now you can see so you can see that for x there is no preference, but for y it goes to the y side. And if we make this drift less, like suppose 0.4, then instead of going to the 1000, it now goes to the 400. So we can again see it goes to the 400. So it always goes to the 400, but the number it's not exactly 400 all the time. So now let's make it 0.1, and now it will say that now it goes to the 70s or 80s, and that depends on the random steps it also takes. Sometimes it goes to 90, and sometimes it goes to 110 also. So you can see that the movement is changing. So so this is you can also see that if I put 0, then it's completely a random walk. So this is how you add a drift into it. So what is the practical example of a drift? So this is more like, suppose you, again we can go back to um, the problem of opening a bottle of perfume in the center of the room. So if you open the perfume bottle in the center of the room, the particles should move randomly in all the directions, and slowly the perfume will be uniformly distributed in the room. But if you have a fan, then the fan will push the perfume particles in one direction, so there will be a drift, and that is how you define this drift. So if you increase the speed of the fan, then you can put higher drift. Like if I put 1, then it goes all the way into the y side. And if I have not that much of power in the fan, then I can say 0.1, and it doesn't go that far, but it still goes in one of the direction. So so another example which is more practical is the movement of the stock prices. So basic assumption in the stock prices is that a stock should return uh, a normal risk-free interest rate. So like if you deposit the money you have used for purchasing the stock, if you deposit that money in the bank, then you get a particular result, interest rate, and that interest rate is risk-free. So that is considered as a drift in a stock price. So you should always get that much of return on average from a stock. But because of the volatility of the market or the fluctuations, it can also go in the negative direction. So normally, like suppose normally in that case, the drift is very low, and the fluctuations are very high. So normally you can say, let's do the uh, so instead of looking in the two dimension, let's look into the one dimension. So I just plot the x uh, plot. So this is more of a one dimension movement, because I am plotting only the x here. And now you can compare this. So let me change the data series and say none and line color solid, and then so this is more of a simulation of a stock price. So here right now I'm using random number from -1 to 1, but the steps will be defined by the volatility of the stock, and there are some formulas. We can talk about that in the next tutorial, and how to simulate a stock price by using the statistics or the parameters which are available about that stock. But here let's just take an example. So now this is a, if you plot only one dimension, then this is a random walk of a stock, and you can see stock can go up, stock can then go down, and this kind of shapes are not very new. You can look at the Google Finance and look at any kind of stocks, and the movement will almost look like this. It goes up and it goes down. There are some people who also do technical analysis. They call it uh, uh, they try to compare it to the technical trends. This is a resistance, this is a support, but what all it is the random walk. We won't call it exactly random walk, because there is also a thinking process going on, because when a stock price goes really down, then there is no much uh, room for it. The probability of it going down is become less, so people start to buy it. So this, that is not completely a random walk in that way, but but at least in financial engineering, people use random walk motions to simulate the price of the stock. So here I can add a drift. So if the interest rate is relatively high, suppose we put 1, so interest rates are relatively high as compared to the volatility of the stock, so you can see the stock will go up eventually, and it doesn't matter what the scenario is, most of the stocks will go up, because the volatility is not there, or much less than the drift. But if the drift is less, that is normally the case in the case of, in the normally the case for most of the stocks. Then if you have a low drift, so or the drift is much lower as compared to the volatility, then it can go all up or down. Or let's try point 1, and you can see that in this way it goes up, but it's there is a fluctuation. But if you try point 0.05, then you can see the movement. Now it still doesn't look much different. Let's try 0.1, and now you can see the drift is almost not there. So now this is the situation of the markets. So you, in case of markets, you have much more volatility as compared to the drift, and that's why the stock price changes. So yeah, so we can talk about how to simulate the stock prices in the next tutorial, but right now we want to focus on the Brownian motion, and we can talk more about the Brownian motion in the next tutorial. So I'll see you. Thank you. um, Hi, in this tutorial we will talk about the Brownian motion. So if a object moves in a random direction, then we call it a Brownian motion. For example, if you open a bottle of perfume in the center of the room, the perfume molecules will diffuse in all the directions, and the movement of these molecules will be random. So slowly the distribution of the perfume molecules will change within the room. So initially the concentration will be most at the center of the room, and then slowly it will be uniformly distributed all in the room. So let's try to simulate a Brownian motion here. So let's do an example. For simulation, we need a random number. So in Excel, you can get a random number by using this command RAND and then parenthesis. So this will give you a random number. So if you click on it again and press, then you will get the number will change. So this number is from 0 to 1. So if you want to get a number between 0 and 2, then you can multiply this number by 2. So this will give you a number between 0 and 2. So like 1.53328, and if I click again and press, this is 0.1614. Now I can also say integer, so int, and then have everything else in the bracket. So what it will do is it will round off the number. So now I will get 1 or I will get 0. So you can press it again. Sometimes you will get 1, sometimes you will get a 0. So you can copy this number and you can see, so you have zeros and ones. So sometimes you have 0, sometimes you have 1. Now if I want a number from -1 to 1, what I can do is I can say 1 minus and multiply this uh, number by 2. So whenever I will get a 0, then it will say 1 minus 0 is 1, and whenever I get 1, then it will say 1 minus 2 is minus 1. So now if I copy this thing, it will give me a number from 1 or minus 1. So if I say again, so see, some of the numbers are 1 and some of them are minus 1. So I can copy them all the way as long as I want. So like suppose I copied around 220. So it's approximate. I don't know how many numbers they are, but so now I can click insert and say scatter plot. So you can see that all of my numbers are either -1 or +1, right? So I can press again and say, so the number changes, but all of them are either -1 or +1. So let's delete this. And now how will I generate a random walk? So let's say that the initial position is 0, and then it, so initial position is 0, and then the next position will be this random step. So I'll say initial position plus the random step. So it will give me the first step, and then I can keep copying it. So if you click on any number again, you will see that what it does, it adds the previous number into the position of the particle or whatever object we are looking at. So you can see that, and when I change or when I press double click on it and press enter, it changes everything. So now I can go and all the way I can again copy it until 220. So now you can see that you press it again, sometimes the numbers are negative, sometimes they are positive. So if I take a graph of this walk, then you can see insert and I say scattered plot, and now you can see that around 200 steps are taken by this particle. So because they are 200, about 200 numbers, and it goes from 0 to 25 and then goes back and goes up. So it's moving randomly, but it can only move 25 steps in a forward direction. But if I click on this again, double click on it and then press enter, then you can see that although it went to 15 units away from 0, but it came back and then it went to the negative side and then came back to the positive. So it's a random walk. So you can keep doing it, and you can see that the distribution or the movement changes most of the time. So this is how you define a random walk. So this is a random walk only in one direction. If you want a two-dimension random walk, all we have to do is we have to generate one more number like this. So we what we can do is I can copy this column and then move or copy this to the next side. So I have two columns with the random steps, and then I can generate same way here and 0 and then say 1 plus or initial position plus the random step, and then I can copy it, double click on the side and it copies. So now I can plot a graph of these two numbers together, and this one will give me another graph which is a random movement in two dimensions. So let's keep this one here. And now if I click again and say enter, or this doesn't look very pretty, so let's do it again. So I think here the what happening is that the statistics is not good, so let's do 1000 points instead of 220 points. So I'll copy all these numbers and go until 1000. Yeah, around 1000 points, and then I'll delete this graph and then choose this and say insert, and then instead of the points I'll say format data series and say none and line color solid. Now you can see this is a random walk. I can delete these numbers so that looks well, and I can also delete these numbers. Let's make another so this is a random walk in two dimensions, so I can double click on it and press enter. You can see that the article movement changes from one to another. So here you can see that I have used the symmetrical step, so it's always 1 or -1. So what we can do is we can remove the int from it, and then it will change the movement. So now let's do remove the int, and from here also remove the int. So now to so now you can see I have removed the int, and I also removed the uh, 2 we had before. So now it's a random number between -1 and 1, and the steps are not symmetrical. So you can see the steps are all between -1 and 1 in column A and B, and then from that we describe the movement. So you can see that uh, the particle is moving in the random direction. So this is about simulation of one particle. So particle can go in any direction. So if we want to simulate a real world problem or the diffusion of some particles in the real world, so instead of using one particle we have to do thousands and thousands of particle simulation, and then we can look at the macroscopic or the bigger picture of what is happening there. So as you can see that the steps are all between -1 and 1. So if we simulate thousands of points together and then take the mean position of that particles, it will be all 0. So the because some of the particle will go in the positive side and some of them will be negative side, but all of the mean should be 0. So and then if you simulate thousands of particles and plot their position from the center, it will be a Gaussian distribution. And as you increase the number of steps, the Gaussian distribution will get flatter and flatter, and ultimately it will become a uniform distribution. So we will talk about that in the second tutorial, and I will also show you how to add a drift into a random walk. So I hope this tutorial will help. I'll see you later then. Thank you.
Hi everyone, in this tutorial I will talk about some animation in Excel worksheet and how to calculate the value of pi using Monte Carlo approach. So here is the program which is already set up. I will show you how to make this sheet, but right now I wanted to show how this work. So suppose I enter here 1000 points. So what does this mean is that, so let me clear this. So when I will click start, it will randomly throw the points on this graph in a square. So that square will be from +1 to -1 in both x direction and y direction. And then these points, some of them will fall inside the circle and some of them will not. And by taking the ratio of the points which are inside the circle, so here you can see point inside the circle and then point in the rectangle, so we can take the ratio of that points, and then from that we can calculate the area of the circle, and from the area of the circle I can calculate the value of pi. And then on the right side you can see this graph which will calculate the dynamic value of pi. So as we increase the number of the points, the value of the pi will converge to the actual value. So let's click start here. So you can see now that uh, so the total number of points in the circle are less as compared to the total point in the rectangle. So this is obvious, and you can see that some of the points are falling outside and some of them are in the circle. And then you can see that the value of pi, so this red line is the actual value of pi, which is 3.14, and then this blue line is the one which is the simulation. So as we increase the number of points, our value converges more towards the real value, so we are more accurate about the value we are calculating. So right now you can see that the value is 3.04, and as we increase the number of points we will get much closer to 3.14, which is the actual value of pi. So let's let it be completed, and then I will show you how did I build this program. So in this sheet you can also see, if I go um, down, there are some numbers here, and then we'll talk about how did I do this calculations. So right now yeah, so it ended and the value of the pi is 3.09 according to the simulation. This is little off from the actual value because we did not use a lot of points, so we need to collect a lot of data to get the real numbers. So because there is always a room for error, so instead of 100 points 1000 points, if I used 50 points, then it will be much more off. So you can see, like, I can say clear and say start, and then see for 50 points it's 3.2, and you can see that there was a large deviation from the value of the pi, and as we go with the simulation or number of points increases, we can go closer to pi. So now how do I make this sheet? So let's look into the sheet. So what I've done is I use VBA. I will show you in a while how did I use the VBA. So I use VBA to generate random points which ranges from -1 to +1. So this column has a random point which ranges from -1 to +1, and this one also has a point which ranges from -1 to +1. And then I take the square of this number and square of this number and add them together, so that will give me the distance from the origin of that point. So let's consider this as x axis, x value, and this consider as a y value. So so now if I take x square plus y square,
So xx plus yy, so this will be my distance from the origin. So, right, so now as you can see, this circle is at the origin, the center is at the origin. So we can define a condition that if the distance from the origin is less than 1, then count that point to be inside the circle, and if that distance is greater than 1, then consider that circle, that point to be outside the circle. And as you can see, because I take the range from -1, so this is only from -1 to +1, right? And then y is also from -1 to +1. So this, therefore this if it can only go from -1 to +1 and y can only go from -1 to +1, that means that we are limiting our points in this range from -1 to +1 on the rectangle. So all the points will fall within the rectangle, but some of them will fall inside the circle. And how will we know that they fall inside the circle? By putting this condition that whenever the x square plus y square is less than 1, then it is in the circle, and if it's greater than 1, then it is outside the circle. So now I just calculate that points here, or count that points here, the number of points in the circle and number of points in the rectangle, and then from that I calculate the value of pi. And here um, I can see, you can see this is the dynamic value of pi which I've calculated. So let me go to the VBA now. So for VBA, you go to the menu of the Excel sheet and go to developer and say view code. So let's go to the VBA. So now I'm not a I'm not trained as a programmer, so I might not be using the right terminology for the part of the programming I've done here, but I will show you how I did it. So here, first of all, you have to define sub, and then the name of the macro you want, or the name of the macro you want to give to your program. So I'll say animation here, and then I put the parenthesis. So now this macro will be named as animation, and then I can define any variable like b is equal to 1 and a is equal to 12. So these are just integer numbers, like same way you do in other programming languages. And now I have a loop, so do until. So this is do until, same, you might be aware, if you have a little bit of programming background, you can say that do this process again and again until this number is less than the particular number you want it to be. So right now I'm saying that I'm saying do until a is less than cell 3 comma 4 plus 11. So what is 3 comma 4? So let's go here and see. So what is uh, 3 comma 4? So cell 3 comma 4 means the third um, row and the fourth column. So third row and fourth column is our number of points, which is 50. So what I'm saying is that do the simulation under until the number of the points will be at least 50. And so here, because I've already defined a to be 12, and I want the simulation to be placed after 12th row. Like you can see, all the simulation starts at number 13. So therefore I have to define it this way, that I have to add the number 11 here because I start with number 12 here. So you can figure that out, that's not very difficult. And then uh, we have to so this is how I define also some variables here. I'm not sure how they are useful or not, but let's go to the main program. So the main program is that cell a plus 1 comma 3, which is 13th row and third column, and it says is equal to 1 minus 2 into r and d parenthesis. So what is r and d? R and d is a random number from 0 to 1, and if I multiply this r and d by 2, that will be a random number from 0 to 2. And then if I subtract it from 1, that will give me a random number from -1 to 1. So what I'm doing here by these two commands is that I'm defining cell 13, row 13, and column C and column D as the random numbers, and as we increment the value of A, it will go to the next row and put the random number there. So now these are two cells which have defined the random numbers, and then we define X as the cell, uh, first cell, which is column C, row 13th, and then Y as another second cell, which is uh, column D and row 13th. So now I define X and Y, then I define distance. Distance is X squared plus Y squared, and then we define if distance is less than 1, then circle points is equal to circle points plus 1. So we have to first define that circle points are 0. So let's say circle points is equal to 0, so that whenever we start the program, it does not should not be defined in the loop, it should be defined outside the loop. And then we have rectangular points. So rectangular points are all the points, so they could be uh, so they doesn't need to be counted. So irrespective of whether distance is less than 1 or greater than 1, they will always be counted. So rectangle points is rectangle point plus 1. And then we define pi, which is circle points, which is circle points into 4 divided by rectangle points. So if you think about it, what does circle point represent? It's the area of the circle, and the rectangular point defines the relative area of the rectangle. And if so, because rectangle is only one, the side is defined as 2, and the uh, so like the X, like if you look at the rectangle, it's the total, the length of the rectangle is 2 and the breadth of the rectangle is 2, so the total area is 4. So that's why we are dividing the rectangular points by 4 to normalize it, and then that will give us the area of uh, the area of the circle is pi r square, and if r is 1, then it will be only pi. So that's why we have divided the area of the rectangle by 4 and then multiply by the number of total points in the circle, and that will give us the pi. So you can do the math, or you can give a comment, I can answer that. So now you can say cell A plus 1 comma 6 is pi. So what I'm doing is I'm putting the value of pi in this column, and then I'm saying cell A plus 1 7 equal to rectangular point, cell 6. So this is now I'm putting the points or the results in the sheet wherever I want to. So like for example, like 6 4 is uh, this column, so number of points in the circle. So I say 6 4 is equal to circle points, 7 4 is equal to rectangle points, and A plus 1, this is again the value of pi. So why I'm putting these points in this column is because I also want to plot a graph, and if I can put the points in the column here, then I can plot the graph for simulations, or for the animations. So now you can see, so here it ends and it says do event. So what this program is doing is, so this do event is important because do event means that one event is completed. So you can see that whatever I simulated, I put it in the do event. So I put do event on the top and then do event in the bottom. So now whatever we are doing is considered as one event. So each simulation will be considered one event, then again it changes the number of points, it again is a second event. So all I have to do is that programming, and then these graphs are normal graphs. I just plotted the graph. I can show you the source data for it. So I say uh, select data, and you can see that this is only the my uh, x value is the random number, and the y value is also y value is also this random number. So I just plotted them, this points as x and y on this circle, on this graph, and then I just drew this circle by myself by putting by putting a drawing here. So now what happened is that when I click start, then
it generates the point, so it generates the random number, and this random numbers appears on this graph because the simulation puts that number into these columns. And as they put so you can see, like, if I say clear, then there are no numbers here, so there is nothing here. And then when I put, say, start, then the numbers are automatically showing up here because of the simulation. And because they show up one by one, they are also plotted in this graph one by one. And same way, because this value of pi show up here one by one, they also get plotted in this graph one by one. So this graph is also just the mere uh, plot of value of pi versus the number of points here. So now so this is how the program is. You can think more about it and it will get clear, but I have already described you the main concept. So again, I can show you the simulation. I say clear, I say 1000 points, and I say start, and then it just start putting the random numbers into the let me yeah, so it start putting the random points into the graph. And this circle is just a drawing, just to visualize how many how many points are in the circle and how many points are not in the circle. And you can see the points in the circle are less as compared to the total points which are there on this graph. And based on the ratio of these points, we take this ratio and multiply by 4. That will give us the value of pi, and the value of pi will get closer and closer to the real value, which is this red line, once we have enough simulation. So as you increase the number of the points, or as you wait longer for the simulation, you will get closer to the actual value of pi. So I hope this tutorial will help. If you have any question, please let me know. Just comment on this YouTube video, and thank you.